All right. Welcome everyone. This is Omar Inam. I am a graduate of FAST Lahore campus. Started there in 1996. With me, with me is Kamran Qazi, is our guest today. He is also from FAST Lahore campus, and he has the distinction of being from the first batch when the FAST Lahore started the computer science program there. In his professional career, he's been working in the telecom space for over 20 years now, where he has done a lot of innovative work. He has a couple of patents to his credit as well, and working for very large companies in the telecom space, like Motorola, Nokia, Alcatel-Lucent, and IBM. Also, he has done many assignments across the globe, and he is one of the thought leaders in what's happening in the telecom space. So why we are here together, given the importance and fast-paced innovation happening in general within the telecom, for example, 5G, what it means, what has happened, what to expect. We feel important that we as a community get more informed and learn from our fellow Fastians who are operating in this space. So with that, we're gonna start this discussion on that topic. Before we dive in, we want to take a minute or so to introduce FAANA and what our mission is, and allow and give you a little bit more background. So for that, I'll request Rafael to give us a quick intro of FAANA and our mission. Rafael.
Thanks, Omar. So FAANA is a registered charity in US, and we are also trying to get our charity status in Canada. Last year, we raised more than $100,000 for scholarships and research and development funds at FAST Lahore, and at basically not only FAST Lahore, all the campuses of FAST. We equally distribute that fund based on university guidelines. There is a lot to Alumni Association, and not necessarily just fundraising. We have 20 plus chapters in North America, and where people can network and connect and help each other out. So anybody who's heading to Canada or US post-graduation, or immigrating to these countries, feel free to get in touch with us, and we'll put you into the relevant chapter so that they can help you out. And I won't take too much time. Just wanted to thank Kamran for joining today's webinar and taking out his precious time. And that's pretty much it.
Thank you, Rafael. So Kamran, over to you.
Okay, thank you, Omar, and thank you, Rafael, for introducing me and introducing the mission of FAANA. So today's session is going to be an overview of telecom infrastructure development, and specifically mobile telecom infrastructure, because that's kind of more prevalent these days, and there is a lot of opportunities, as Omar mentioned. Telecom in general is encompasses the wireline as well, but we're not going to talk about that today. So during my assumption here is that being CS graduates and with that background, a lot of us have not been exposed to this area. So that is why, when Omar and I were talking, we felt that, this is the area which we should introduce today. It is an ocean. I'll give you a brief overview of that ocean. And depending upon where the interest is, how the questions come in, and where people feel we need to do sort of like a deep dive, we can do follow-on sessions as well. And there are lots of career opportunities, lots of business opportunities as well, especially with the latest trends in IT and the telecom, especially this mobile telecom kind of fusing together. Previously, we had not seen that trend, but recently that trend is very obvious. There are companies jumping in left and right. So we'll touch upon that here as well.
Kamran, just one thing I forgot to mention earlier. For the audience, please feel free to raise your hand and ask questions. Don't be shy. We just want to have a conversation style discussion as much as possible. We have saved quite a few time to open Q&A, but as Kamran mentioned, if something he's talking and you feel him to answer your question right there, right then, please chime in. Either type in the chat box or raise your hand, and we will give you opportunity to ask your question. Thank you.
Thank you, Umar. So this is our brief agenda for today. We are going to again take an overview. So during the presentation, I will not only introduce you to the functions of different architectural components of a mobile network, but I will also highlight where the opportunities are, where the carriers are, and so on. So without further ado, let's jump into the very first slide. So mobile network architecture, we all use smartphones, we all use some kind of, mobile device, some kind of user equipment, as we say in this industry, is called a UE. And then we access the internet, we access the voice services to talk to our friends and families and others. But ever wondered what's all in between these two ends of the spectrum? So here is a brief introduction of what encompasses this mobile network architecture. I think the first and foremost, you must have noticed that there are these cell towers which are very obvious to the public eye. So that's very noticeable, and people know that there are cell towers and there are radios on them, and so on and so forth. But then what's behind them, that leads your call or leads your data stream all the way to internet and the voice services. So before I jump into each one of them and the details of each, there are two types of companies in this space. One is called what we call a communication service provider, or CSPs, or sometimes we also call them mobile network operators, or MNOs. And the other type of company is the infrastructure provider, infrastructure developer, and these are sometimes called vendors as well. So when we talk about CSPs or MNOs, you can think of AT&T and Verizon's and T-Mobiles of the world. And when you talk about vendors, you think about Motorola, Nokia, Alcatel-Lucent, Huawei, and companies like that. And there are many more companies that are jumping in now due to the recent trends. From the UE side, I think a lot of people are familiar with this. A lot of people are also, especially CS graduates, they are in this business of developing apps, mobile devices. Manufacturers like Apple and Samsung and others, they are coming up with new models, every year, every few months, and so on. We're not going to speak about that today. We're more interested in the infrastructure side. We know the nature of the UE. The UE is a very sophisticated radio. If you recall back in the old days, when we used to, have those radios only for entertainment or for the news broadcast services. This is a very sophisticated radio which uses the same radio frequencies in different spectrums and transmits data using those radio frequencies. So on the other side, you have this tower, and that tower has the radios and the antennas which communicate to the UE or to the user equipment using those radio waves and radio frequencies. Now, in this space, first of all, this radio frequency is regulated. You must have heard recently about some spectrum auctions that have taken place over here in US. Verizon spent multi-billion dollars just to procure their license or their right to transmit in a given frequency. So that's regulated. And then when it comes to laying out a network, where opportunity is and where carriers have been in the past as well, is RF planning. RF is radio frequency, RF planning and RF optimization in this space. With 5G, this is going to be even more crucial, more prevalent, because 5G, the cells are going to be small, and you will need to provide focus services, focus bandwidth, in certain areas. So this is going to be, much more involved going forward as well. So since this is the most precious commodity, as I mentioned, that Verizon and others, mobile network operators, they spend billions of dollars in procuring those licenses. It is very important that the radio and the logic that is behind, using that radio frequency is utilizing this RF frequency in the best possible fashion. So this is where radio R&D and antenna R&D comes into play. People who are interested in that area, they can search for it. They can figure out who is doing what in that space, and can associate with them as well. The other thing that is their opportunity is the construction and maintenance of radio sites. That's a very civil kind of job, but that's also there. Behind the base station, now once the behind the tower is the base, is the you must have seen maybe a small cabinet or a shelter that is built either at the base of the of the tower, or in an office next door, which is called a base station. And that base station, its main job is to utilize that RF frequency, utilize the radio frequency to transmit and receive data. So it's primary. There is a scheduler in there, and that scheduler is responsible for utilizing that those millisecond and microsecond burst of radio waves to the UE and from the UE in an optimized fashion. The other thing that base station handles is UE registration. Obviously, it is utilizing or it is dealing with multiple UE streams at any given point in time. It also participates in handovers when when the UE moves from coverage of one base station to the other. It utilizes that the services of the base station. There's a lot of R&D in this space, very exciting application where this whole dealing with the streams that are lower layers of networking and scheduling and all that. So this is where I started my career back in Motorola about 20 plus years ago. The other thing from a usage perspective is the installation and maintenance of these, because they have to be up and running all the time in order for the service to be available all the time to the users of the mobile network. So that is where the preventive maintenance, the ongoing fault resolution and things like that happen as well. Now, a base station does not know about all the subscribed users in a given network. So if you're talking about AT&T or Verizon, for example, one base station would not know whether this particular user that is coming in now in this coverage area is really authorized to use the services or not. So that is where the base station talks to a central entity, which is called the core network. Core network is shown as a cloud over here, but this cloud has a lot of nodes behind it. I'm not going to go into details. Again, this is an overview. At some point in time, if there is interest, we can dive deep into that as well. But this is where your whole subscriber database resides. The authentication, when the user initially comes in, that authentication happens with the core network. The core network also acts as a mobility anchor. So for example, when the UE moves from one base station to the other, the IP addresses that were allocated to the UE to start with, if they change and the data streams are interrupted, then it defeats the purpose of having this mobile network at first place. So this is where this in collaboration, core network in collaboration with the source and the target base station, make sure that the stream of data that was going in or out of the UE does not get interrupted even when you're going through a handover. There are lots of routers and gateways inside this core network. which have a specific function, and that function, either the data stream is going towards the data side, which is the internet, or it is going through an IMS core, which translates, all of this, packetized voice back into a PSTN type voice channel, so that you can call a landline or call other voice services, multimedia services, and things like that. There is policy enforcement happening over here, security, and so on. So again, another ocean or sea within an ocean, which has a lot of potential, a lot of carriers and business opportunities as well. Overseeing all of this is what is called an operations and management framework, or operations and management nodes. FCAPs stand for, fault management, configuration management, accounting, performance management, and security. So this is something, when you put together this network and you're operating it, these are everyday kind of tasks. There are faults coming in, new base stations are coming in, or there is a configuration change, there is accounting of what all is happening for billing, for other KPIs, monitoring, things like that, performance and security. So this, in a nutshell, is what a mobile network architecture is. Are there any questions at this time before I move on?
There is one by Numan Sheikh. Numan, can you say that question to Kamran?
Yeah. So I am more interested in trying to understand what is fundamentally changing with 5G, or is this going to remain the same as it has been for the last 10-15 years?
Yes, Numan, good question. And this is the topic of today's discussion. In the next 2-3 slides, you will get your answer. If you can hold off a little bit, please. Okay.
Sounds good.
All right, so moving on. So these are our mobile network generations, right? 2G, 3G, 4G, 5G. There was 1G as well, but 1G was completely analog. Much the same way the radio was broadcasted in the past, for cricket matches and news and things like that. It was pretty much using that for the mobile calls as well, but we're not talking about that. So starting with 2G, which was the GSM area, I think some of you have been here long enough to remember those GSM days. That's where the move happened between analog and digital signal. So GSM went digital radio frequency. They called it enhanced voice because now it was digitized. So, noise and things like that, they were better than what it was back in the analog space. And then with 2.5G, the standards bodies, they also introduced what is called packet data. At that point, kilobits per second was considered luxury. I remember testing, back in those days, 80 kilobits per second, and we were dancing on the floor that, hey, we have achieved something really big. So that was the time at that point. Then came in 3G, which is where efficient use of radio frequency was introduced. So every time you see, this is a trend that when you go from one generation to the other, the radio frequency, as I mentioned earlier, it is the most precious commodity in this whole game. And the name of the game is how do you make the best use of that radio frequency to pump in the most amount of data in the best possible way to make the best money for mobile network operator. So that efficient obviously as compared to 2G, that was introduced, call it enhanced voice. Smartphones were introduced, back in the 2007, 2006 timeframe. I think that's where the first iPhone came in. That was on 3G. And high-speed data was introduced, and that was in megabits per second. So again, this was considered luxury back then, that we had an improvement from 2G to 3G. Then came 4G in 2010 and beyond. Again, even more efficient use of radio frequency. MIMO is massive multiple in, multiple out. Which is, you utilize the multiple paths of radio frequency when radio signals are coming in, they could hop on different objects and you could receive multipath gain on your antenna, either in UE or on the radio. So this MIMO technique was introduced at that point. Voice over IP, TV, video, things like that, they were introduced, and high-speed data, hundreds of megabits per second, was introduced at that point. With 5G, is it really a game changer, or is it just another gimmick to say more speed and so on? So we have a specific slide on that. We will talk about that, but just briefly here, 5G is talking about ultra low latency. 4G, the latency of each packet, or ping latency, let's talk. I think most of us are familiar with ping. Ping latency is on the order of 20, 30 milliseconds. In 5G, you're talking about single-digit latency, 1 millisecond, maybe even better than that. Right now, it's not there, but that's the target for 5G. Broad range of radio frequency, we'll build on that in a later slide. User density for Internet of Things and applications of that nature. User density on a per square kilometer, you're talking about 1 million users now, with 5G. With 4G, each cell and with a given frequency use, it wasn't even coming close. And obviously, couple that with high-speed data in gigabits per second. So that is also on the charts here. So Numan, it is a game changer, and I'll tell you how in the next 2 slides. The standards bodies that control these standards on how these protocols or these different nodes talk to each other, there are many, but I'm just naming a few here. 3GPP is third generation partnership project. And they control most of whatever happens between the base station, the core network, the UE. So pretty much all the interfaces that you saw, I'll jump to the previous slide, all these arrows that connect the nodes together and so on. There are standards for all of these interfaces in 3GPP. Other standard bodies, they also control some architectural side and so forth. So this is for your reference. ORAN Alliance is a new thing that is coming in, where 5G has enabled this OpenRAM concept. What is OpenRAM? Let's talk about that a little bit. So I'm going to introduce another concept here, which is before we kind of weave this together, which is network function virtualization. So back in the old days, the applications or what you saw in the past, those base stations, core network nodes, they were done in a traditional way. Traditional way in the sense that there is a physical machine, there is an operating system, there is an application. It's married together in the sense that that physical machine is a custom hardware built for that particular application. Because these are telco applications, they don't run on a normal PC or a normal laptop or of that sort. So this used to be the case for, I would say, most of the time until 2012, 2013 timeframe, when this new network function virtualization concept was introduced. So what does that do? That disconnects the application. We can call it softwareization as well. Disconnects the application from the physical machine. So you can have a physical machine, you have an host OS, you introduce a hypervisor layer, it virtualizes, what you call the hardware or the resources from that physical machine. Then you install your guest OSs, you can install many of them, and you can have your applications on top. It's still, I mean, it's a nice concept. It had its value. It is still being used. But then the recent concept of containerization, where you're talking about lighter weight containers with applications, libraries and configs all contained in a single container, which can be orchestrated and which can be scalable and which can move around from one physical virtual machine to another. This concept is now fusing with the 5G, with the mobile infrastructure. So this is where the value of 5G comes in. You're talking about, you're moving towards a virtual everything now. Previously, with this concept, with the virtual network function, you were talking about, virtual routers, you're talking about virtual SGSM, virtual base station, but they were still kind of, stagnant and married to a particular form of physical machines and so on. Now you're talking about, you can take these containers pretty much anywhere where there is, quote unquote, any flavor of cloud. So now you're talking about not only the cloud for the users, but you're talking about cloud infrastructure being utilized for the telecom infrastructure. So this is the unique.
Kamran, a quick
concept.
question. When you say cloud usage, are we talking like hyperscalers like Amazon, Google's of the world? Are telcos moving there, or is it more specialized clouds?
Both. This is the beauty of it. This way of doing the telecom infrastructure applications, you can host these containers on AWS, Azure, Google Cloud, any other cloud flavor, or some big telcos, they're still kind of, what you call a little bit skeptical about using the public cloud. So they are installing their own private clouds using their own cloud recipes, either using Wind River, using Red Hat OpenShift, or other flavors that are available in the market. So good question, but that's the beauty of it, that now these applications can host anywhere. Okay. Now let's put this all together. Any questions? Any other questions, Omar?
I haven't seen any in the chat. Rafael, anything on Facebook stream?
No, I think we're good for now.
Okay. So this is where, you put this all together. So 5G is that game changer. First of all, let's talk about one concept, which is the single digit latency. So what they did was, in this radio, they had a fundamental change in the frame structure of 5G radio. So it can support frequencies ranging from 600 megahertz all the way to 40 gigahertz and more. Why this is important? The lower the frequency, the better the penetration, but the scarce it is. So in today's world, for example, getting a spectrum allocated in 600 megahertz or 800 megahertz range, you only get 5 to 10 megahertz. Maybe, if you're lucky, you have 20 megahertz contiguous spectrum. 20 megahertz can only pack these many bits that you can utilize for 5G. But as you go higher up, for example, if you go to 39 gigahertz, for example, which is the millimeter wave, you're talking about spectrum allocation of 800 megahertz. So now you're talking about 1 gigabits per second, 10 gigabits per second, and things like that. However, the penetration is low, and you need sort of like a line of sight. So the radio and the UE or the user equipment have to be, without any obstruction. They have to be a line of sight with each other. So this is the wide range of spectrum that is supported by this, by the 5G standards and the 5G new radio. This is where you're talking about mission critical applications. You're talking about self-driven cars, etc. You must have read about news about, performing the surgery where the surgeon was several miles away and they were performing the surgery remotely on a patient and so on using this technology. The other thing that is changing is the massive machine communication. This is where the number of users that will be supported by the 5G infrastructure is going to be in tens of thousands, hundreds of thousands, and millions in a particular square kilometer or in a particular footprint area. Now you're talking about Internet of Things, industrial automation, smart cities, and things of that nature. So these kind of applications are enabled by the 5G standard. Enhanced broadband. So we already spoke about that. Target is 10 gigabits per second. but I myself tested at least with 2 gigabits per second already. In one of the areas here. You're talking about augmented reality, virtual reality, you're talking about ultra HD applications, things of that nature. Another very unique concept to 5G is network slicing. So previously, if you have a network, you have basically fine-tuned that network depending upon the foot traffic or the mobile traffic in that area. If you are in an urban area, you fine-tune it for a lot of users, but with lower throughput, lower bandwidth. If you're talking about, for example, a highway, you're talking about a broader coverage, decent throughput, and a decent latency, things of that nature. But with network slicing, what this enables is, with containerization and all, what this enables is that the operator can create a network, a virtual network slice end-to-end, and create a virtual network on the go to serve a particular service. For example, it could be you can set aside a network slice for emergency services. God forbid there is a big emergency event that happens in a certain area. Everybody in that area is now making phone calls and making data calls. All your RF is choked, right? You're not going to get any channel. When the emergency services come on that location, how are they going to communicate to their controllers and all? So that's where network slicing is going to come into play. You will have a network slice set aside for emergency services. Similarly, in a given area, you're talking about 2 networks maybe running side by side on the same infrastructure, with one fine-tuned for higher bandwidth, the other fine-tuned for more number of users. Opportunities are unlimited here as well. The one other thing that is enabled by 5G, especially the core side, is the microservices architecture. So microservices architecture is where all of those services or functions that I mentioned earlier, those are now exhibiting themselves as independent services. So if a service is there, you talk to each other. If the service is not there, you still are adaptable. Your network is still adaptable. It can still function, but without that particular service. It is also scalable depending upon the need. You can scale those containers, different instances, and you can have a more adaptable and resilient network. Other things that are changing here is private enterprise networks. I'm not sure if you've seen this recent Amazon announcement. On the AWS service dashboard, which has many services, you will now see that there is a service where you can procure a private enterprise network. So everything is hosted on AWS, except for the radios, of course, because the radios are physical commodity. So Amazon will send you those radios, and you can have your smart office or an automated factory or whatever other location you want to install your private enterprise network. You can actually procure that from Amazon. So this was recently announced. All of this is possible because 5G is going on this microservices containerized architecture. OpenRAM is another concept, very interesting concept, where you're talking about interoperating components. So previously, back in the old days, I named a few companies which were in the infrastructure business, and they were the sort of like sole providers of the infrastructure because nobody else had the infrastructure to come up with those infrastructure equipment. Now with this containerized architecture and disconnecting from the custom-made hardware, anybody could just read up that spec. They can write their own component, write their own service, and they can start selling it to other vendors, or they can start selling to the operators. So this is a very, very interesting enablement. Lots of companies are actually coming in this space only. The company that I currently work with is a big pusher of OpenRAM. So this is a very interesting development. And this will definitely interest Naman. I know RAN intelligent controller. So much the same way you have applications which are quote unquote plugins for your or which can come into your mobile phone, change its behavior, or you can utilize those applications on that same platform. You can now have RAN intelligent controller, third-party plugin applications. You can implement machine learning, analytics, self-optimizing RAN network, and so on and so forth. So this is another very interesting area where there is a lot of potential. If you understand how the network operates, and if you have something to offer from capturing those KPIs, implementing some smart algorithms, and do something regarding either optimizing or improving the quality of experience for the user, I think you are game. You have a business case here. Let me stop here. Any questions so far?
I have one question. This is very insightful conversation thus far, at least for personally for me, learning about all these trends and where like software applicability, given that we mentioned that goal is to go virtual with everything, which means that predominantly outside of physical network and physical servers, everything is software driven, which is amazing. So the question I have is about reliability. When we talk about self-driven cars, I'm personally very interested in when we're gonna reach that state that we don't have to drive anymore, and the cars will talk to each other. How does reliability is going to be a critical thing. Security will be another critical thing. How are those being addressed, or what are the areas where we should focus on, maybe developing some new offerings or developing new solutions for that?
Right. As with any other new technology, some of these areas will get addressed as we go and gain experience. So if you're asking for any quick answers at this point, those answers might not be there. But as you know, initially when the technology comes in, sometimes it is big, chunky, clunky. But then as you start to use them, some first technology adopters, they start to use them. That provides tremendous amount of data to the technology developers, right? This is where people on this call and other companies who are in this business, they come into play. They look at that data, and that's where the innovation light bulbs come on, and you figure out how do you solve this problem so that it gets better than what it was before, right? So as you're talking about reliability, so initially the self-driven cars, you might actually need a very specific corridor on which you will have these mini or pico 5G cells all over the place, right? And then the data is being captured, transmitted, bounced off of the network, and the instructions are given in near real time. Remember, the latency is now single digit here, or at least that's the target. But still, it won't be 100% accident proof or something. So God forbid, if there is some accident that happens, then data needs to be analyzed, figured out why it wasn't reliable, why it did not respond in the given time that it was supposed to, and then you improve it. So that's the kind of evolution cycle that we have to go through. Usually, for each one of these generations, if you look at the trend, starting from 2G, 3G, up to 5G, each one of these generations, it takes up to 10 years to fully evolve to unleash its full potential. Back in the 1990s, that was the 2G era, 3G was the 2000s era, 4G was the 2010s era, and now you're talking about 2020 and beyond. Did that answer your question, Amar?
Yes, thank you.
Yeah. Did we raise our hand? I'm sorry, I haven't asked a question. Mohammed Ali from Toronto. Kamran sir, thank you so very much. This is a very, very engaging discussion. You were talking about accidents, etc. Bottom line is, right now we are driving manual cars, etc., operating machines manually. There are accidents that happen. So if using machines and using new technologies, if the percentage actually reduces, it can never be zero, but if it reduces, that's always going to be a positive.
That's correct. That's the goal. And then, for the users, what are you gonna do during that time while the car is self-driving you to work or, wherever you want to go? So can you utilize that time for something else more meaningful, right? So that's
absolutely more productivity, efficiency.
Yeah. Salman said he has raised his hand. So Numan, let Salman go first, and then you can proceed. Salman.
Assalamu alaikum. I just had a question about how would edge computing be changing with the advent of 5G, as we have seen 2 or 3 phrases where at one point in time there were thicker clients, then they got thinner, then they got thicker again. So now with 5G, with this containerization coming in for all the microservices, would edge be thin again, or would there be a hybrid model in use in terms of edge computing?
So actually, Kamran, I have a follow-up. There's a similar line. My question is on the edge. Right now, one of the biggest problems with edge computing is the real estate, like the hardware that I can put on an edge device. So we normally collect data from the edge, bring it to a central point, figure out what to do, and then push the instructions back to the edge. Is this going to fundamentally change where we can process some of these things on the edge without the addition of additional hardware on the edge by using the communication layer?
Yes, excellent question. So let me go back to the first slide here, which was the architecture slide. So if you look at this, the base station, and Salman, this will address your question as well. So the base station, this was the edge, right? Where the data was being collected. However, the bandwidth between the base station and the core network was limited. This is, again, precious commodity, requires a lot of SLA and a lot of money that operators have to spend to connect all of their base stations, thousands and millions of them, across the country and across the region. So now what is happening is that with 5G standards, they have split the functionality of the base station, where the central unit is moved back in the core, and only what is essential to process the radio frequency remains on the side. So, and that is called a DU, which is the distributed unit. And the other one is called the CU, which is the central unit, and that went back to the core. So a lot of the data that previously we were interested in, but we were not able to get a hold of from the edge, is now going to be available in the data center or in the server farm that you can now easily utilize to have your analytics and so forth. Does that make sense, Numan and Salman?
Yes.
But I mean, are they going to let third-party applications to run on it?
Absolutely.
So if I'm providing a solution to a client for an IoT and there's a specific application that I need to run on this layer, would they open it up?
Right, exactly. So this is the other thing, right? So even the DU, although it has to serve to a physical network function here. So that's how we distinguish virtual network function, which is VNF, versus physical network function, which is the radio. Radio cannot be virtualized, at least not so far, right? So this DU has to serve that physical network function, and it has to be in close proximity of that, right? However, that DU application is still a containerized and cloudified application. So it is still orchestrated by the network orchestrator that sits in the core somewhere. If there are third-party applications, those third-party applications can also be pushed to that node to be able to utilize that data locally over here. We call it far edge now, on that far edge, and only send out what is meaningful, or the analysis, or maybe do some optimization on the fly on that particular node. So that is still a possibility. Yes.
Okay, one more follow-up on the same lines. This is specific to Pakistan. River flow monitoring in the agriculture space and some other agriculture and forestry related use cases where we are looking to use drones. If permanent sensors are placed out in the wilderness, in the middle of nowhere, does this help with the communication extending out to areas? Does this include increase the radio coverage?
So you will need to have the infrastructure to be able to, I mean, all of these, call them 5G towers now, right? Or 5G radios. You will need to have those available on that terrain so that those drones or sensors can actually talk to the network, right?
So from the
obviously,
device to the antenna, that distance limitation is still there.
That distance limitation, it depends on your application, on the kind of sensor you have. So remember, there is a wide range of coverage here as far as the frequency is concerned. The lower the frequency, the better the penetration and the bigger the cell. So you could have a 600 megahertz cell, which covers, let's say, 5 kilometers, or you could have a 39 gigahertz cell, which only covers 200 meters, and everything in between. So it depends on the application and depends on the availability of that device or that radio at this point, so that you are able to quickly get this off the ground. Otherwise, you'll have to go ask for that to be built, custom made for that application. And I think that's certainly a possibility as well. Or this could be an entrepreneurial kind of a deal. You could start your own business or start your own company there.
Okay, thank you.
Did that answer the question, Naman? Or, I mean, we can talk offline as well if there is.
Yeah, no, I got the basic idea, yes.
Yeah, okay.
Salman, is your question addressed or we need to revisit?
No, that is addressed too. Thank you so very much.
Okay. So we have about 10 minutes. Kamran, any other slides that you have to cover, or we should open it up for further Q&A?
No, this was the last slide. So
okay.
I thank you all. You can reach out to me offline if you need additional guidance. If you want to bounce off any ideas, I can certainly be available to discuss that further.
So another trend that is emerging, there's a company called Starlink. Tesla, Elon Musk leads that. How are they leveraging 5G in some form or shape when they like send satellites and enable internet in remote areas, or is there a different infrastructure or technology?
Quite frankly, I have not studied that company, so I can't comment. I will look at it offline.
Okay.
And get back to you.
All right. So for people on the call, any other questions that you may want to ask to Kamran?
Well, okay, I'll go again. I'm still kind of curious about the possibilities that this is opening up if I have faster network communication going on between the device, smart device, phone, or any edge device, and the central hub, wherever my servers are, where the actual data processing happens. I mean, what are some of the most popular use cases that are encouraging these network operators and other companies to invest billions into this? What are they looking to fundamentally change? I mean, with 4G or LTE, I get pretty good coverage of video streaming wherever I am, and video calls are fine with a little bit of hiccups here or there. So, but just to improve that little bit of experience improvement, they wouldn't be spending billions. So what is fundamentally changing here?
Okay, good question. So I don't want to sound judgmental here, but let me tell you what is in your question. What I sense is that this is still from the user side, right? So you're talking about from a usability perspective, what is the end game for the user? You know, how would the user benefit? All that, right? But you know, the aspect that I was coming from was opportunities in network infrastructure development. So why that is important for operators is that these base stations, radios, core networks, there are hundreds of different companies who used to manufacture these equipment on custom hardware with custom applications. So there is maintenance, there is licenses, there is upgrades, everything had money involved for the operator. So for the mobile network operator, this was getting quite an expensive ordeal to operate a network end to end, because now, you know, one person is saying yes, or one company is saying yes, I can upgrade this, but the other company is saying I cannot upgrade this until you pay me these many millions or whatever, right? So then now you're stuck with that base station older model because it can only interoperate with the older model of the core network and so on. So what is fundamentally changing here with this openness, OpenRAM, containerization and all, is that that total cost of ownership for the operator is going to go dramatically down, right? So from an infrastructure development perspective, also previously in the traditional sense, and let me go to this one, right? In the traditional sense, people who used to manufacture, the companies who used to manufacture these devices or these equipment, this was a very custom made, very specialized work, and only a few companies in the world had that capability. Now with containerization, this is opening up to a mom and pop shop, you know, an entrepreneur of 5 people sitting in their garage, and they can come up with applications for the telecom infrastructure, right? And they can sell cheap, right? They don't have the overheads of big companies now. That physical machine, this physical machine in the traditional sense, and this, you obviously know that is changing now. This was a monolithic, specialized hardware. This is now COTS hardware, your HP and Dell blade servers of the world.
Great. So Kamran, would you see virtualization of the mobile OS itself? So we would have these smartphones without any OSs, and they would launch and get the OS at real time from the 5G service that they are connected to in future?
You would still need some kind of an OS, right? Whether it's a host OS or a guest OS. I'm not sure. I have not thought about this question, but you would still need some kind of an OS. That's my first answer.
Thank you.
What it means, whether you can change it on the fly, if that's what you mean.
Yeah, like a Chrome OS model, where like every single time your OS is upgraded, latest and the greatest, and because you are getting it as a virtualized service from the 5G, so maybe just a shell remains on the smart device now, and everything is virtualized.
Right. There might be some use cases that may benefit from that kind of a model, but and some use cases may continue to follow the way we do today, right? Or iOS, you have it, you upgrade it. A lot of processing is happening on the iOS. So, yeah.
So let me one more point I wanted to make to Numan is, so Numan, with this, right, where you're going with this is, like, this is the start, this RAN intelligent controller, where you're talking about third-party plugins. So see how the landscape of mobile applications changed when they opened this marketplace and the app store, right? There are billions of applications, and you can, no two cell phones in the world are probably alike, because everyone has their own, excuse me, favorite applications and usage and so forth. So this is again another thing that where the operators want to invite innovation from the people who can come up with some smart application, sell it to them, and then they can in turn offer it to their end users and make money from that. That would be new revenue stream there. So that's
Kamran, I see one more hand up. Gohar has a question. Gohar, you can unmute and ask.
Thank you. So this is just an auxiliary question to what Salman asked. So we understand that between 4G, 3G, and 5G, the infrastructure has tremendously improved and whatnot. So my question is kind of what are the protocols? So are these protocols changing the 4G to 5G, the IMS and the cores? Because you mentioned the RAN intelligent controller. So if the same protocols are still functioning in the core of that part, then that means that any new entrepreneur still has to learn all of those previous protocols to actually get connected to the market. So if there's something new, that means anybody from the garage could learn those protocols right at the birth of them and be a company of that. But right now they have to compete with the giants in that industry, the masters of that protocol and those tools. So do you see any shift in those protocols and softwares?
Okay, very good question. So now this is the question on the right lines here. If you look at this, the standard bodies, that's why I mentioned them here. If you go to 3GPP's website, you will see different releases of those protocols. And those releases, they started back in 1999. That's where the first 2G or 2.5G release was published. And if you click on that and you start looking at the specifications for each protocol, right? And this is the same way your TCPs work and IETF RFCs work. So you look at that. It's not an easy document to read, but it will tell you what messages are exchanged between different nodes to accomplish the given function on that interface. And then from release 99 onwards, pretty much every year, they published a new release, right? I think now they are at release 17 or 18. 5G was introduced in release 15, I think, if I'm not mistaken. So those protocols are building on their base, which is the release 99, and then they are enhancing it, every year to be able to accommodate the new trends and the new applications and new way of doing things. So if you're a new player, and you want to jump right at 5G, you would still have to go look at, the release 15 or whichever release you want to comply to, and implement those protocols such that wherever your application or your microservice sits, it makes all the other nodes and application and services happy from a protocol perspective, because these are standardized protocols. If you cannot interoperate with other microservices, nobody is going to talk to you, right? So you would have to comply to that and make sure that you are interoperable with those other microservices and nodes that you plan to interact with. However, again, I would still encourage that this is still a possibility with the new way of doing things. Previously, with the custom hardware, it was difficult. It was challenging. It required a lot of investment. Now this is possible.
Okay.
Did that answer your question?
And there's one more. Is anyone has a question? Okay, so I'm seeing a trend. A lot more new people have joined in the last couple of minutes, and I'm sensing due to the time change in the US, the time that we announced for people joining from Pakistan, they're probably joining now, whereas we're ending in the US, and that's basically a miscommunication on our side. I think we'll address that through the replay, given the session was recorded. So with that, we should conclude here today. Before we do the wrap up, anyone has any question? All right. So thank you, everyone. With that, we're going to conclude today's session. People who just joined a couple of minutes ago, I apologize. There was some miscommunication. We started an hour earlier due to the change in time in United States. The session was recorded, and we will be sending out the link to the recorded session shortly.